say we were doing 4.4, graphing linear equations. This is found in your sections of notes for the Math Essentials course. Our goal is to graph linear equations in the coordinate plane. First, let's talk about what is a linear equation. A linear equation is an equation of a line. So we can fill this in. An equation that represents a straight line. A standard form of a linear equation looks like this. AX plus BY equals C, where A and B are just constants. They're any number. And Y and X are dependent upon each other. A linear function looks like Y equals MX plus B. Sorry, frozen for a second. How would you decide if a point was on a specific line? Well, if it's on this line, it has to make this line, this equation, true. So if I look at my point here, my X is my 1 and my Y is my 3. So if I put those into this equation, I put 1 in for X and 3 in for Y, and I get 1 plus 3 equals 4. If that's true, then that point right there will lie on this line. Let's check to see if negative 2, 7 is also a point on the line. So this is my X and this is my Y. So if I put negative 2 in for X and 7 in for Y, so negative 2 plus 7, I'm following this equation right here, is supposed to equal 4. I'm going to adjust this a second, see if we can get a better picture. Okay, negative 2 plus 7 is 5. That does not equal 4. So this is false. So this point is on the line, this point is not. Let's try that again. Number 2. Y minus 4x equals 10. Same thing, I can just plug this in. So this is my X and this is my Y. So I'm going to say 11 in for Y minus 4 times 2 for X equals 10. I need to do this part first. So negative 4 times 2 is negative 8. So 11 minus 8 equals 10. And 11 minus 8 is actually 3. And 3 does not equal 10. If we get a false statement here, that means that this point is not on the line. Let's try 1 and 14. So 1 is my X, 14 is my Y. So 14 goes here, minus 4 times 1 equals 10. 14 minus 4 times 1, so 4 times 1 is just 4. It's negative 4 because there's a minus here. So 14 minus 4 equals 10, and that is true. So if we find out that that's true, then this point satisfies the equation, and it is on the line. Okay, let's go down here to this example 1. Solve each equation by. So we're just trying to get y by itself. This is something we worked on last set of notes that we did. So circle our y, because that's what we're trying to get by itself, and anything outside the bubble, I need to move to the other side of the equation, or subtract it from both sides, or add it from both sides. So since there's not a sign in front of this x, we assume it's positive. So I'm going to subtract x from both sides. Now I cannot subtract x from 10, so I'm just going to write it out to the side here. So on this side, those two equal 0. So I have a positive y equals 10 minus x. Now remember, we want this to look like the linear function up here. Y equals some number times x plus another number. Okay, so I need my some number times x first. So I can move my x to the front. And since there's a negative in front of the x, that negative goes with the x. So if I were to rewrite this, I'd say y equals negative x. And then the sign that goes with the 10, there's not a sign in front of it. So we know that must mean it's positive. So we say positive 10. And that's how we would rewrite that equation. Okay, and the rest of this part of the notes is something that we covered yesterday extensively. So we're going to skip over this, turn the page. We're going to talk about graphing a line. So one method for graphing the lines is to create a table of values or ordered pairs. Graph each point on the coordinate plane and then connect the points to create the line. So we're going to graph each equation by creating a table of points. So the first step is to solve for y if it's not already by itself. Number one, y is already by itself. So I'm going to make a little table, x values and y values. Now it doesn't matter what I pick for x. I can pick any number I want. I could pick 100 if I wanted to, but that would make our graph a little bit complicated. So we're going to try to stick with small numbers. I usually like to pick 0, 1, 2, -1, -2. That keeps me pretty close to the middle of my origin here. So let's just start with 2. If we plug a 2 in for x, we have 3 plus 2, and that equals 5. So y equals 5. And I can graph that point and go over 2, up 5. 1, 2, 3, 4, 5, right here. There's 1 point on my line. Now let's try the number 1. If I plug 1 in right here, I get 3 plus 1. So y equals 4. So this is another point I can put on my line, 1, 4. So over 1, up 4. 1, 2, 3, 4. Okay, let's try 0. If I put 0 in, I get 3 plus 0. So my y is 3. 1, 2, 3. 0, 3 is right there. Now we can see that is enough information. All I need is 2 points really to draw a straight line. I just wanted to show you it's good to try a few more just so that you can make sure that you did your math right. So let's connect those points right there with a ruler. Okay. Let's look at number 2. The first step is to get y by itself, and since y is not on a side all by itself, I need to get rid of anything else on that side or do the inverse operation. So since this is a positive x, I have x plus y, a positive x plus y. I'm going to subtract x from both sides. So let me rewrite this over here. I'm going to subtract x. Now I can't subtract x from 4, so I'm just going to put it out here. And I get y equals 4 minus x. Now if I make my table of points here, I get x and y. And we can use, let's start out with 1. I'm going to pick 1 for x. So I have, put it in right here, and I have 4 minus 1. So 4 minus 1 is 3. Y equals 3. Let's pick 0. 4 minus 0. 4 minus nothing is just 4. So y equals 4. Let's plot those 2 points. 1, 3 is right there. And 0, 4 is right there. So I'm going to plot one more just to make sure I did it right. But my line should go just like this. Okay, let's do a -1. Now, this is where we always have a little bit of problems here subtracting a negative. So 4 minus, I'm going to write this one down, 4 minus a -1, y equals that. Whenever I subtract a negative, it's the same as adding that number to it. So 4 plus 1 equals 5, y equals 5. So I have -1, positive 5 right here. And since that falls exactly where I thought it was going to, I know I must be doing it right. So I'm going to connect the points. Now I showed some of you guys how to use Desmos yesterday, that online calculator. If you were to go into Desmos and you inputted that value right there, then you would see this line, and you would be able to check yourself and know that you were right on that. So it's something kind of nice about that. Okay, let's do just a couple more here. Number 3. So the first step is to get y by itself. So I'm going to rewrite this over here just so I have a little bit more to work. I'm going to slide this right here. All right. So 2y minus 4 equals 6. 4x, excuse me. Okay, now I'm trying to get y by itself. So I'm going to circle my y right here. That's what I'm trying to get by itself. So anything outside the circle right now is going to be added or subtracted to the other side. Since I have a negative 4, I'm going to do the opposite of subtracting 4x, and I'm going to add 4x. But I can't add 4x to 6, so I just have to write it to the side of it. So on this side, I have 2y, I didn't do anything to that, equals, those two cancel out, 6 plus 4x. And I can just leave that as 6 plus 4x, because I can't combine. Now I have 2 times y, so I need to do the opposite of multiplying y by 2. The opposite of that, or the inverse operation, is divide it by 2. Now when I divide this side by 2, I have to divide the entire opposite side by 2. So every term, everything that is divided by, or is separated by a positive or a negative is a term. So 6 is a term and 4x is a term. So I need to divide 6 by 2 and also 4x by 2. So on this side I have y equals 3 plus 2x. Okay, and then I can graph that from that. I'm going to make my little table of values here, x, y. And I'm going to make x be 0 first. We'll turn the screen back on. And I have 3 plus 2 times 0. 2 times 0 is just 0, so I'm left with 3 here. If I plug in a 1, I get 3 plus 2 times 1. So 2 times 1 is 2. 3 plus 2 is 5. Let's try a negative 1. So I have 3 plus 2 times negative 1. 2 times negative 1 equals negative 2. So I have 3 minus 2, and that gives me 1. All right, let's plot those points. 0, 3, 1, 2, 3. And then I have 1, 5, and negative 1, 1. And since they all lie on a straight line, I just need to connect them together. I know I did it right. Okay. Now what if I have one like number 4, where it just says y equals some number? I could think of that as that no matter what point I pick for x, so if x is 1, then y is 3. If x is 5, y is 3. If x is 0, y is 3. If I pick x as negative 2,000, y is still going to be 3. So if you see that if I connect my dots right there, it makes a horizontal line. Y is always going to be 3 no matter what x I choose. So I don't even have to pick points or do anything. That one's pretty easy. What if I have x equals a number? Let this come into focus here. Okay, x equals a number. I'm going to use the same logic. No matter what y I pick, so let's say y is 1, x is always going to be negative 5. 1, 2, 3, 4, 5. If I pick x as negative 5, or I mean y as negative 5, excuse me, x is still going to be negative 5. So no matter what, x is always going to be negative 5 for every y that I choose. So this one is a vertical line. Okay, one more. This one makes it nice and easy because we don't have to solve for y. All we need to do is first start out just by plotting our points. So I'm going to make my table x, y, and I'm just going to pick points for it. So let's try 0. If I put a 0 in for x, I have 2 times 0, which is 0, minus 1. And if you don't like that I'm doing this in my head, you can write it out as well. So negative 2 times 0 is 0, and then I subtract 1 from 0 and I get negative 1. So 0, negative 1 is right here. Okay, and then I'm going to try the number 1. I'll plug this in. I'm going to fix this screen just a little bit. Okay, I'm going to plug a 1 in. So I have negative 2 times 1 minus 1 equals y. So negative 2 times 1 is a negative 2, and I subtract 1 from that. Wait for the video to catch up here. It's frozen on me. There we go. So negative 2 minus 1 is a negative 3 because the signs are the same. So I'm getting a bigger negative number. So it's negative 3 equals y. So at 1, it's negative 3. If we try, let's just try 2 this time. So I want you to see you can always try any points. You don't just have to use 1, negative 1, and 0. If I plug a 2 in for x, I'm going to write below negative 2 times 2 minus 1. And I get negative 2 times 2 is negative 4 minus 1. And they have the same sign, so it gets bigger. 4 plus 1 is 5, and I keep the sign. So y equals negative 5. Let's plot those points. So I already plotted this one. Don't know why my camera's struggling here. Hopefully it comes back on. But you can keep working while this is coming back on. There we go. So 1, negative 3 is right there. And then I have 2, negative 5. There's over 2, down 5 is right there. Okay, they all lie within the same line. So I can use my straight edge, draw my line. Okay, your homework today is 4.4 worksheet. It's due next time you come to class. So we'll pass it out right now during class, and you can begin working on it.